Okay, so good morning. It's Friday, September 12th. We're here in our Ann Arbor facility, and we're here trying to get our Thermolift device into the test cell so we can have our initial testing phase and see if we can move some heat, because that's our goal. Our goal is to be a heat pump.
This is a very exciting stage of the program. We've been several months both designing various iterations until we came to a design freeze and came up with the design we wanted to build.
We'll power up the burner. The burner's wiring is temporary for now, but we can run the burner and put some heat to it and see how it works.
So sometime back in 2012, a good friend of mine and co-founder of Thermolift, Dr. Professor Peter Hofbauer, told me I needed to quit my job, go into the basement of my house, and start a company called Thermolift, which is the development of the ultimate heat pump, a natural gas-based air conditioner and heat pump technology. Heat pump technologies take advantage of two forms of heat. They take advantage of the chemical heat in the fuel, and they take care of energy that's stored in the environment. Everywhere outside there's heat. If we can take heat from outside the house and put it inside the house, we burn 1 unit of fuel, and we can capture a partial unit of heat from outside. We can burn 1 unit of fuel and get 1.6 units of heat into the house. What that does is it's going to cut fuel consumption by up to 50%.
I must say that this particular project has really generated a lot of attention. I think that's partly because of the promise that it has to basically revolutionize home heating by using natural gas in a very efficient way. And also, the project itself has a lot of core technology, and it's a very natural link with the university. So there's been an awful lot of excitement here that we've seen.
So we've built this critical mass of business people, technologists, and technology development assistants to bring Thermolift to market. We found a true champion of the technology in Bob Cattell, the former chairman of National Grid, the former chairman of the American Gas Association. Eric Coffey is our program manager in our Ann Arbor facility. Eric has got extensive engineering experience in electronics and electronic controls. Next to him is David Yates. David is our lead design engineer. Back on the management team is Jonathan Haas, who was introduced by Stony Brook through the Clean Energy Business Incubator program. Dennis Lin, who's an advanced thermodynamics specialist. We have Matt, mechanical engineer. Sean Convey, who's a material science engineer. So the team of David and John and Sean and Dennis and Paul, along with Andrew out in Detroit, along with Lisa, who's handling all of our electronic controls, has reached a critical mass to put the Thermolift into production.
Thermolift has submitted grants to the Department of Defense. We've submitted grants to the Department of Energy and NYSERDA and local and state institutions. The DOE and NYSERDA have both provided funding to us in excess of $1.2 million in 3 separate grants. As a result, we have been validated as a disruptive technology that can have a far-reaching impact on the way that heating and cooling systems are installed and utilized in this country and across the world.
We have been, since December, accumulating parts, assembling parts, putting those parts together till we can get to the Generation 1, or our real first prototype of the Thermolift device. So we've been working 12 to 15 hours a day so we can get it into our test cell, fire it up, and see what kind of heat we can pump.
Somebody watching the temperatures?
670, 700, 708.
The Thermolift prototype that we're building today does not have all the answers to the technology, but it will prove the most important aspect of that technology, and it's the independent motion of displacers.
I'm trying to run them insane.
They're both moving.
Both NYSERDA and the Department of Energy has told us that if we reach certain benchmarks, that they'll be there to help us go forward. And our investors are confident that Thermolift can achieve those performance goals, and will be there for the continued development of the technology. And we hope to launch commercial production in 2016 and 2017.